Hello and welcome to another video for Introductory Chemistry with Dr. Dan. So with this quick video, we're going to just go over how to name binary ionic compounds. And what that means is whenever you have something that is considered to be binary, is that we have two distinct species in this compound. So for ionic, it has to be a metal and a non-metal that are bonding together. So whenever we have a metal and a non-metal, they're going to be labeled as a cation and an anion. So if you kind of remember that cats are always positive and that anions are negative, we'll be able to figure out which species is which. So what we're going to see is that the cation is always going to be the metal in these different situations. And the anion is always going to be a non-metal, and this comes from where it's located on the periodic table. We're going to go through how to name these. So when it comes to naming an ionic compound, the metal is listed first. And what we're going to just do is just put just a name that you see right on your periodic table, followed by the non-metal. That anion or non-metal is going to have its ending replaced. So for example, if I have something like fluorine, for example, that ending is going to get replaced. So we're going to keep the first syllable. So if you have fluor and ene, so that's two syllables, we're going to get rid of the second half of that, and it's going to be replaced with the ending ide. So let's go through a couple examples of how to do this when we go into the different steps of how to name these. So if I have this first one here on the left, so we have KCl. So what we need to do is find both species. And one thing you're going to see is like, okay, well, there's potassium right here. As you notice, it's on the left side of this zigzag over here. So what that means is, oh, we're on the metal side of the periodic table. And then we have our non-metals over here. So metals are going to be listed first. So what we have here is we have potassium, and I don't know why I put a B. We have potassium is our metal, and then it's going to be followed very quickly by the non-metal. So we have chlorine, which is our non-metal here. So potassium chlorine, but we're going to be replacing that ending. So the chlorine, so we look at the two syllables that are here. We keep the first. So it's just going to become potassium chloride. So just like sodium chloride, but in this case, it's potassium instead. So if we go to the second one, I have Ca and S. So let's try to find the metal and the non-metal. So we find that we have Ca over here, which shows that it is calcium. And then when we look for sulfur for S, it's under my non-metal label over here. And we can see sulfur, so it's going to be calcium and sulfur. So let's put both of those species down. So the metal name stays the same. The only thing that's going to change is the non-metal. So we keep that first syllable, which is the sulf part of it. So it's going to be calcium sulfide. And that is our name. We drop that last little bit and we change the name for us. Okay, let's try another one. So we have RbF in this case. So we have Rb. So what is that? Not Arby's, but Rb, the element. So we have rubidium in this case. So Rb is first. So let's spell out rubidium. That's a hard one to spell. So we have rubidium and then followed by fluorine, which makes it fluoride. And if you're not sure how any of these different things are, if you check from the very beginning of the slide, I have all the different halogens here and all the different main nonmetals that you will be seeing very commonly in your chemistry classes. So here's a quick little list for you if you'd like to refer to it for later going through these. But you can see with rubidium and all these, they're all being replaced by the ide ending with those nonmetals. So whether it's fluorine, chlorine, bromine, they would become fluoride, chloride, bromide, iodide, oxide, sulfide, nitride, and so on. All right. Then what about this next one? We have AlN, and hopefully if you recognize that element, that is aluminum, followed by nitrogen. So make it aluminum nitride in this case. All right. So what if we go the other way though? So what if I have just the names here? So we have magnesium bromide. Okay, so going backwards, so we have to figure out what are the subscripts for all the different species so that we can cross our charges and practice our swap drop method. So with magnesium, we got to find that first. We know metals are always listed first, so it's going to be on that left side of the periodic table. So if we let's clean up our work here for a second, we can see that magnesium is right over here. We see that Mg, that's going to be our first species. And we want to write down the charges, right? So it's Mg, and if you kind of remember our predictable charges based on our columns, that'd be 1 and 2 plus. We might as well fill in the other ones over here, where if we remember there's no charge for the noble gases, -1 for fluorine, -2, and -3. All right, so bromine is in the -1 column, and magnesium is in the +2 column. So let's write those down. So we have magnesium and bromine. We have 2 plus for magnesium, -1 for bromine. We're going to swap drop those charges just like our previous videos. And that's going to show how we're going to be balancing those charges. So you can go both ways depending on whatever species we are going to be working on. So what if we have a metal with a variable charge? So before, whenever we had a predictable charge, one that is known from the periodic table, this is something that has always the same one. So it's referred to as a type 1 compound. Now the transition metals, so all the area in the middle of the periodic table in those d orbital blocks. So right here in the middle, we have the transition metals on our periodic table. These ones can have varying charges. So whenever you have something that can be multiple different types of charges, let's try to see if we can get one of them based on any of these different possibilities. So one example could be, let's say if I have copper and chloride, for example. So if I have CuCl2, or I could also have a species of CuCl. So how would I determine what my charges are and all those little pieces there? So for metals with variable charge, the big thing is that they're always, the entire ion or ionic compound is neutral. So meaning the charge for this entire species is 0. So if that's the case, we can go off our predictable ions that we know from our periodic table. So if we kind of go back up, we can see chlorine, right, is a known charge of -1. It's in this column here that is in that -1 column. So you know it's going to have that charge. So let's go back down below. So if we know that, right, we know it's always going to be a -1 charge. We see that there are 2 chlorines due to this subscript here. So what we can essentially say is that we have 2 -1 charges. And what that's going to be balanced against is whatever this unknown charge is of copper. So we know, though, we have 1 copper. So if I can say, all right, well, we have 1 copper that's here, and we'll show that maybe in green, but we don't know what its charge is. So we do know the whole thing is going to be equal to 0, though. So let's just do some simple little math. So if I take 2 times -1, that makes -2, and it's going to be plus some kind of unknown charge is equal to 0. So what charge is copper? Well, copper is our question mark. So if I add 2 to both sides, what we're going to find out is that the charge is +2. So how do we go about naming this thing? Well, with variable charges, it's actually a really simple system. We use Roman numerals to help us name these. So if I have copper, we're going to list our metal like normal. So we just list out copper. We know it has a 2 charge, so we'll put the Roman numeral for 2 out. And it's going to be followed by chloride, just like before. So in case you forgot what your Roman numerals are, right, we have 1, 2, 3, 4, 5, and usually it doesn't go above 6, but we'll write them all out just so we have them, 7, and then 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. So if I wanted to try the other one that I had here, I had CuCl. We can try doing something very similar for this, right? You know that chlorine is a -1 charge. So how would we balance out copper in this case? Well, we would need a +1 charge, right? It's like balancing scales. They need to be the same on both sides. So being that's the case, this would be copper 1 chloride. And that really emphasizes the idea that you can have many different possible charges for these species. So if we're going to try one last one, let's say if I give you PbS2, how would we figure out the charges? Well, first you're going to go off of what you know, which is sulfur, right? We can go to our periodic table and see what is the charge of sulfur, which by looking, you can notice it's in the -2 column. So we can then determine, all right, well, lead is, we don't know the charge of lead, but we do know that every sulfur that's here has a -2 charge, and there's 2 sulfurs. So what is the overall negative charge? Well, the overall negative charge is going to be -4. So how do you balance out both sides? Well, your lead is going to need a +4 to balance the sides of the scale. It needs to have the same amount of negative as positive when it's a neutral compound. So if we were to name this, it's going to be lead 4. Then we're going to take that sulfur, drop the ending, and it's going to become lead sulfide. And that would be our final answer. I hope this video helped a little bit, at least get some headway on making ionic or naming ionic compounds. And please check out some future content in the future, and I'll keep making videos. All right, see you all later. Bye.